thumbs up. Hi, today I'm going to talk to you about the basics of artificial neural networks. You may be asking, what are neural networks? In biological neural networks are the pathways in your brain that neurons create to send information. Then that's how your body works. And artificial neural networks are computational models inspired by the biological ones. So let's go back to Biology 106 and how do neurons work. So these are two different neurons, and the information is passed across the synapse to receptors on their dendrites. And when the transmission reaches a certain threshold, the neuron is activated and it sends information down its axon to the next neuron, where the process will repeat or end depending on how it takes it in. Here is an example of an artificial neuron. So you have your inputs and an output, and in between there are some other things. The weights are what determine the strength of the input, and then you can have one or multiple functions, and the final function will result in the output. And if you want, your inputs are defined, and you're trying to get the right output. So if you want to change your output, you change your weights. And different types of neurons have different ranges of outputs. Some are just binary, like a logic gate, you get a 1 or 0, but most are more complicated with larger outputs. A network is made up of layers of neurons, where each layer can have multiple neurons or nodes, and then the input of the next layer is the output of the previous layer. And you'll notice in the middle we have this hidden layer, and those are where the functions are happening, where we do not see the information that's being, like the steps there, we do not see the information from there. We know our inputs and we know our outputs. And so why is this important? Because it is used in machine learning. Machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. That's what it sounds like. That's from Arthur Samuel, who's the father of the machine learning field. So we use machine learning to solve tasks that, if you want to, coding out a very specific algorithm would be tedious and maybe wouldn't even result in what you want. We use artificial networks specifically, or not me personally. Artificial networks are used for lots of things that we use in our everyday lives. Image identification. Here you have, Google has identified this image as containing a dog and a hat with a wide brim. We've got Siri. Siri uses speech recognition to answer your queries. And the classic example is handwriting recognitions and identifying digits that someone has written and reading them. How does a network learn? There are two kinds I'm going to talk about today. Unsupervised training and supervised training. They're both okay, even though we've got our unaccompanied minor. So in unsupervised learning, the network receives the data and a corresponding cost function, which lets you know what the cost of getting that output was, which could be efficiency, time, space, whatever you are concerned about. And you run the cost function on the output, and you use the results to update the weights so that you'll get, hopefully, a smaller cost and find your optimal relationship. Supervised training, you have inputs and the outputs you would like from them. You have like an example set, and so you can put them through first with randomized weights, and then you can adjust the weights until you get outputs that are closer to your intended results. And this is usually done with a back propagation algorithm, which is basically just a way of calculating the margin of error and transmitting it back through the network so everyone knows how to adjust accordingly. And the reason I wanted to learn about artificial neural networks is because of Google's Deep Dream software, which is super cool. Google's Deep Dream presented Deep Dream. It's a visualization tool to help us understand what neural networks are actually learning and how the individual layers are functioning. So if you want to know what a network knows, and these are visual networks. They actually are modeled after our occipital lobe business. So you can give it just like some static and say, I want to see a banana, please show me a banana. And as you can see here, the network is pretty good at identifying a banana. You've got that curved yellow shape. But in the second image, you're asking for a dumbbell, and you see these dumbbells come with arms attached. So you can see that your input for trying to find a dumbbell, you don't have any, you don't have enough that are by themselves. They're all attached to people's arms, which makes the computer think that dumbbells and arms are one thing. And if you want to go into the different layers, which are generally hidden, Deep Dream is a way to do that. So you might have seen, like in the bottom picture, the scary dogs. That's a common Google Deep Dream output, and it's one of the higher level layers, and it identifies more complex features and brings out what it thinks it sees, which is often a lot of dogs. And the lower level ones, they focus on shapes and edges, and so you get more of like a painterly stroke. And the Deep Dream code is open source, so you can use it to edit your own photos, which is super fun. Dreamscope app is my favorite one of these. And so instead of getting this like terrifying picture of spaghetti that is like sort of your standard Deep Dream output, you can take a picture of your cohort members and give it sort of the weight that you'd like it to look like. So here we have us, and then I gave it a Picasso painting, and now we are in the style of. In the middle we have a Bauhaus textile, and the bottom we have a Miro painting. And so it uses the Deep Dream software on a more basic level to create these fun images. And thank you. I hope you look into it more.